Okay, guys. So what we're going to do today is we're going to go over chapter or section 2.2. This is all about angles formed by parallel lines and their properties. Now, the properties are pretty straightforward. That's not the problem that people run into. It's to use these properties now to solve things. So I'm quickly going to go over the two properties that you probably have heard of before. But we'll quickly go over those, and then we'll use the information that we've been given to actually solve things about properties or of parallel lines. So this is a little bit of some geometry stuff, and we're going to be proving things about it. Okay. So the first thing we're going to talk about is alternating interior angles, or the old AIA for shorthand. Whenever you got to talk about this stuff, always use shorthand. It just makes it easier. So basically, what it says is when a transversal, this guy here, intersects a pair of parallel lines, the alternating interior angles are equal. So this guy, angle C and angle F, are equal. These two guys, so the inside angles that are opposite one another on the opposite sides of the transversal are equal. And always look for this. They form a Z. Okay? So this guy is a backward Z. All right? Always look for those angles inside the Z. They're going to be equal. Now the next one is co-interior angles. So angles on the same side of a transversal that are inside the parallel lines, they are not equal, they're supplementary. All right? And remember, supplementary means equal to 180. So basically what this states is C plus E equals 180, or D plus F equals 180. Okay? So those are the two big things. Now with this guy here, this forms the letter C. So this guy here, it's a forward C, this one's a backward C. So you're going to be looking for Z's and C's in this unit. And the key is to not get them backwards, and also to be able to see them in shapes that don't necessarily have two nice parallel lines with a smooth transaxial coming through, or transversal, sorry. So it can be a little tough to see things at times. But with a little bit of practice, just like anything in math, it gets a little bit easier. All right, so let's try one here. So here what we want to do is we want to determine the measurements of angle A, B, C, and D. Okay? So to do that, what I like to do with geometry, like whenever I'm dealing with anything like this and I'm trying to show something, I use a statement reason table. All right, so basically what this means is I'm going to say something and I'm going to give a reason why that's true. All right, so statement reason. And I recommend doing this. This is what I would like to see preferably on tests. And I would also like to see this because it makes it easier for you guys to keep things organized, okay? So I can tell right away that angle A equals 110. Oh, that's 110, not 100. Okay? Now the reason you can give for this is that these are corresponding angles. Make sure I spell this right. Alright, corresponding angles. Then with that, I could say that angle A equals angle B, which equals 110. And the reason I know angle A equals angle B, these are vertically opposite. Okay, so I just put vertically off for shorthand. You could put VO if you wanted to, that's fine. Now, so I have A and B, now I need C and D. So if I look here, I can see that A and C are the inside angles of my letter C. So that means angle A and angle C add up to 180 degrees. So I could say A plus C equals 180 because those are or the co-interior angles, the CIA. Okay, so that means angle C equals 70 degrees. Okay, but I don't need to give a reason for that because once again it's just C, my co-interior angles. And then I know that C and D equal one another. Angle C equals angle D because they are vertically, or alternating interior angles. So they're going to be 70 degrees, alternating interior angles. And there, it's done. I've proven what every angle is. I got C, D, A, and B all in there. So this one's done. Okay? So this is what you use a statement reason table for. You give a statement, and then you tell me why. Okay? Now, for the next one here, so this is example 2. This is also in the textbook. I believe it is on page 77. We want to go through here and we want to prove that these 3 lines are all parallel. So once again, I'm going to set up a statement. Alright, just give myself enough room. Alright, so first thing I'm going to do is I'm going to look at angle CGB, and I'm going to say that that equals angle GBF. So CGB is this angle here, and CBF is that angle here. So I know they're both 35 degrees, and the reason I know that is because that was given to me. So I'm going to say now line CG equals line BF. And the reason I'm saying that is because these 2 angles were equal, so they are alternating interior angles. Now I'm going to move on to, I'm going to look at line BF and line AE. So I could say that angle FD20 equals angle BEA. Once again, the reason for that is because they're given. So now here I can say, well, if these 2 angles are the same, I can say that those are alternating interior angles, so these 2 lines must be parallel. So I can say that BM, not equals to, sorry, that should be parallel. It's parallel to line AE. Okay, reason for that, alternating interior angles. So now I've proven that these 2 lines are parallel. I've proven that these 2 lines are parallel, so therefore I will say that all 3 lines are just parallel. That's line CG. Yeah, line AE is parallel. Okay? So once again, the statement reason table makes it really nice to work with this stuff. All right, last example here that I want to go over. This one we're not so much proving what 2 lines are or are not. We're actually looking for the value of the angles themselves. Now this one, here we have 2 parallel lines and we have a transversal passing through, and we're looking for the co-interior angles. And we want to know what they're worth. And here we need to actually solve for x and then figure it out. So you need to solve for x. We have to do some actual algebra here, okay? Good little review from Math 10. So we know that these 2 angles, because they're co-interior angles, we know that when you add them up, they equal 180. So you know that 2x plus 43 plus 2x minus 3 equals 180 degrees. So now what you need to do is you need to solve for x. That's really straightforward. You just combine like terms and then figure everything out. So 2x plus 2x is 4x. 43 minus 3, that's just 40. And now I just isolate and solve. So I subtract the 40 from both sides. And then I divide everything by 4. So x is going to be 30. Alright, so now I know what x is. I can solve for these two angles. The first one, I'll label this one number 1, this one number 2. Number 1, I'm going to take this x value now, and I'm going to plug it into the equation. So it's going to be 2 times 30 plus 43. And that's going to equal 60 plus 3, so that's 103. Now for angle 2, it's going to be 2 times 30 minus 3. Okay? So 60 minus 7, or 60 minus 3 is 57. All right, hold the phone, I made a mistake. Right here, 180 minus 40 is 140. Now I divide that by 40, or by 4, sorry, 140 divided by 4 is 35. So now I got to go back. It's not the end of the world. That's not great, I apologize. So it should be 2 times 35, and that should be 2 times 35. So 2 times 35 minus 3 70 minus 3 is 67. And now 70 plus 43, that's going to be 113. There we go. That makes sense. And the reason I caught this is when I finished it, I realized when I add these up, at first they didn't add up to 180. And now when I add these up, it's 180 degrees. So I did my check. So that's what you do. You set this up based on things that you know. Like I know that these two angles had to add up to 180, so I add them together here and here to give me 180, and then I solve algebraically. Just make sure you do your math right, otherwise it looks kind of embarrassing. Okay, so if you look at the bottom of the page, there's some good properties there to remember. All the things that we've talked about with parallel lines so far in this unit, 2.1 and 2.2. So make sure you guys understand this stuff. I'll put the assignment on Moodle and you go from there. Cool.